Today we're going over chapter 2, section 1. We're talking about functions. A function is a relation in which each element of the domain is paired with exactly one element of the range. So domain are the x values and the range are the y values. So what does this mean? For a function to be true, there are no repeating x values. You can repeat the y, so you can repeat the range, but the x does not repeat. We have different types of functions. You're not going to need to know if it's a one-to-one function and onto function, both one-to-one and onto. I'm just going to go over how they look. We have the one-to-one function, which is each element of the domain pairs to exactly one unique element of the pair, of the range. So that means, in this case, the domain is 1, the range is D. The domain is 2, the range is B. The domain is 3, the range is A. So nothing really repeats. Then you have the onto function, which is each element of the range corresponds to an element of the domain. Domain 1, range D. Domain 2, range B. Domain 3, range C. Domain 4, range C. This is when I told you that the range can repeat, but the x cannot. In this case, the C repeats, but the x or domain doesn't. Then we have a both one-to-one and onto. What does this mean? That each element of the domain is paired with exactly one element of the range, and each element of the range corresponds to a unique element of the domain. So that means all of the range and all of the domain are paired off to exactly one of each. So one domain per one range, and so on. Keep in mind, non-functions have at least one x value with two or more y values. So if you have an x that repeats, it's no longer a function. When you do it graphically, let's say you have a point here, 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 and the graph looks like this. Remember that we can do the vertical line test. If we were to draw a line here, in this part that they share, the x value, then it would not be a function. We learned the vertical line test last year. If it passes the vertical line test, aka no x repeats, then it is a function. So for the next slide, they want us to state the domain and range of each relation. Then determine whether each relation is a function. So I'm going to write the domain. The domain are all of the x's, so it's going to be -6, -5, -3, -1, and 6. And then we have, I'm going to write the range as well. -1, -9, -7, 7, and -9. Now keep in mind the domain is in order from least to greatest, and the range is to the one that it corresponds to. In this case, they gave us the points in order, while in the other one, in other problems, you may not have them in order. The key is make sure that the x is in order from least to greatest, and then for the range, just make sure they match. So -6 goes with -1, -5 goes with -9. If it is not in order, it will be marked wrong, even if you do put the numbers correctly. So make sure they go in order. Now, we have to determine whether each relation is a function. In this case, it is a function. The reason it is a function is because no x repeats. I'm going to write the reason. No x value repeats. So to state the domain and the range, I'm going to do the same thing I did before. Domain. We have, again, going in order, -2, -1, -1, 2, and 2. And then for the range, I'm going to make sure they match. So 0, -1, 1, -2, 2. Now, determine whether this relationship is a function. It is not a function. Again, this will be sufficient enough unless it says explain. Then the explanation would be the x values repeat. So state the domain and range of each relation, then determine whether each relation is a function. Now for 1a, the domain is going to be the x value of all of those individual points. So we're going to get -3, -2, -2, -1, 0, 1, 3, and 4. And then for the range, again, it's the y value from all of those points. Now for the range, they don't, like I said, you should match it when it's a graph and a chart. So let's do it. It's going to be 2, 1, -2, 1, 2, -2, -3, comma 4. Now the first one, state the domain and range of each relation, then determine whether each relation is a function. For this function, it is not a function. We have -2 repeated right here. Now for 1b, state the domain. It's going to be -3, -2, -1, 0, and 1. And the range is going to be 0, 2, 6, 4, 8. Now, this one, it is a function. Because the x does not repeat. Now the vertical line test. If no vertical line intersects a graph in more than one point, the graph represents is a function. Again, like I mentioned at the beginning, if we were to draw a vertical line at any point in any of this graph, at least the left one, it would be a function because it only touches the graph once. If I were to draw a line at any point on the graph on the right, notice how it always touches 2 points, except for right here, which only touches 1. As long as the vertical line test fails once, it is no longer a function. It just has to fail once. Doesn't matter if you draw the line five times or 1, as long as it only fails once, it's no longer a function. So if we draw a vertical line across this circle, it touches at least twice, so it is no longer a function. As it is it's not a function, it just has to fail the vertical test once. Now for the other graph, I can draw a vertical line anywhere in this graph, and it only touches it once. So this second graph is a function. Equations that represent functions are often written in function notation. We also talked about it towards the last chapters of Algebra 1. The equations y equals 5x minus 1 can be written as f of x equals 5x minus 1. So suppose that you want to find the value in the range that corresponds to the element -6 in the domain of the function. So you would plug in the value of f of -6 is found by substituting -6 for each x in the equation. Therefore, f of -6 equals 5 times -6 minus 1, or 31. So to explain what's going on here, you have this equation. All they're doing is changing y into f of x. That is just another way of saying y. Now, why is function notation important? When you're going into a lot of larger problems and you have it in function notation, let's say we want to find -6, just like they did. They substitute this x with a -6. So when you solve it, we're using the exact same example they use. When you solve it, you're able to tell what your x is, x being the number you plugged in, and what your y is, which is what it equals. So this would be the x of that pair, and this would be the y of that pair. Now it is important just because it helps you keep organized. Now, don't stress if it says f of x or g of x or h of x. It's the exact same thing. It's all values, a different name for y, just with a different variable. And the x just means for the domain, and what we get out of it will be the range, will be the y. So it's just good to know and understand how functional notation works. So for a, they have f of x equals 2x squared minus 8. They want us to find each value. They're telling us for a, or the only question here, they want us to find is f of 6. Notice how the 6 just takes the place of the x. So we do f of 6 equals 2 times 6 squared minus 8. And then we can actually go ahead and solve the right side of the equation. And we will get the domain. We will get the range for the domain of 6. So f of 6 equals 2 times 36 minus 8. And then it would be, again, following PEMDAS, 36 times 2. So f of 6 equals 72 minus 8. And then f of 6, after simplifying, 72 minus 8 is 64. So the range for your 6 is 64. So it would be 6, 64. The order pair of the solution, again, domain, range. So here they want us to evaluate the function f of negative 3. And they give us the function f of x equals negative 4x minus 8. So it's going to be f of negative 3. Again, just changing the x, negative 4 times negative 3 minus 8. So f of negative 3, negative 4 times negative 3 is 12 minus 8. We're going to get f of negative 3 is 4. So your order pair would be negative 3, 4. Your domain again, and then your range.